Next one, let's look at basic probability rule number 3. Two events, A and B, are disjoint. Or some book call this is mutually exclusive. So for this course, I'm going to use disjoint and mutually exclusive alternatively, okay? Sometimes I say it's disjoint, sometimes I call this is what? Mutually exclusive. If they have no outcomes in common, and so can never occur simultaneously. If A and B are disjoint, then probability A or B is PA plus PB. If A and B are not disjoint, then probability A or B is PA plus PB minus PA and B. How are we going to see this in a more intuitive way? Well, we can see like this. If we assume S is equiprobable, if we assume S is equiprobable, then probability A or B can be written as number of outcome in what? A or B divided by number of possible outcome in the sample space. And we just wonder, is this number is equal to what? The summation of these three probabilities. PA, number of outcome in A, divided by number of outcome in the sample space. PB, number of outcome in B, divided by number of outcome in the sample space. And probability A and B can be written as number of outcome in A and B divided by number of outcome in the sample space. But number of outcome in the sample space, this is a number of possible outcomes. S is what? The sample space of the random experiment. And therefore this number must be what? Greater or equal to 2. If when we multiply a positive integer on both sides, well, that is to say we actually checking what? Number of outcome in A or B, is that equal to number of outcome in A plus number of outcome in B minus number of outcome in what? A and B. And this is what we have covered earlier. In general, number of outcome in A or B is equal to number of outcome in A plus number of outcome in B, subtract the one repeats. And the one repeats turn out to be what? The common outcomes. So this is true, means this is true. Okay? That means what? This is true. So if we assume sample space is equiprobable, we can understand this identity what? In a very intuitive way. And next one, property or rule number 4. Next one, let's look at rule number 4. For this one, I'm going to give you a very what? Simple proof. Okay? Recall the Venn diagram. This is sample space. This is what? A. And the shady area is simply A complement. From this one, you can easily find out A and A complement share nothing in common. But A together with A complement give us the whole sample space. And to prove rule number 4, we're going to use this. Okay? Now, first step. 1 is equal to probability of the sample space. That means sample space will happen for sure. This is from rule number 2. Now, what is S? S is what? A or A complement. But from rule number 3, A or A complement is also equal to PA plus PA complement. And then subtract by what? PA and A complement. Okay? However, A and A complement, they share nothing in common. So this one is empty. Okay? And that is to say, 1 is equal to PA plus PA complement, because this term is 0. And that further implies PA complement is simply 1 minus what? PA. Okay? Done. You want to copy? Go ahead.